So thank you for joining us. My name is Laura Kastenbauer. I am from Clean Water Action, Minnesota. I'm the Field to Fork program organizer. So Field to Fork has to do about sustainable agriculture. We're focused on how farming, and especially factory farming, directly influences water quality. And we want to combat against it. So we want to make sure that everybody has safe access to drinking water. And we know that with a lot of factory farming that happens in the area, it cannot happen that way. So we're here trying to support sustainable agriculture initiatives, and we're here tonight to kind of talk to you about soil health. So I'm going to introduce our two hosts. We have Professor Anna Cates. So she is Minnesota's first state soil health specialist in the Minnesota Office for Soil Health. Minnesota Office for Soil Health is dedicated to improving soil health in Minnesota by working with farmers and conservation professionals. Anna's research focuses on soil, organic material cycling, and storage in a variety of cropping systems. She received a PhD in agronomy, I cannot pronounce that tonight, and an MS in soil science from the University of Wisconsin-Madison. So thank you, Anna, for joining us.
Thanks for having me.
Yeah. So I am going to have Anna take it away now.
Okay. Thanks for that introduction. I'm going to talk a little bit more about who I am and where I'm coming from. Do you see my slideshow okay and hear me okay and everything? Great. So yes, as she said, I work for the Minnesota Office for Soil Health, which is a new organization in the state. It's largely funded by the Board of Water and Soil Resources with some contributions from the Minnesota Water Resources Center. So you can see that a big reason we're pursuing soil health is for water quality, water resources regions. And I'm going to be talking a little bit more about that as we go through it. I should say that my position is focused on working with row crop farmers. I think about how to reduce nutrient loading and preserve our soil kind of in that major land use. So I might not be as helpful as some of you might like with the gardening and lawn type questions. That's just not the area I focus on. I'm interested in that stuff. I planted some seeds in my own garden today, but I don't have the kind of research-based expertise. I always recommend talking to master gardeners in your area. And sometimes there's a horticulture educator too who can be helpful. Okay, so where am I coming from? What do I know about agronomy, soil science? But how did I get into this? I think I did get bitten by the agriculture bug at a pretty young age. My parents ran a cow-calf operation in southern Wisconsin when I was a little kid, and my cousin and uncle now raise grass-fed beef on that land. And, something about being surrounded by the cattle and the pasture as a little kid, I think did kind of sink into me. Because after I graduated from college, I started working on small farms and was learning about, organic vegetable production on the, 1 to 50 acre scale. I still grow quite a few of these dry beans for my family, but that's kind of my only agricultural pursuit right now. At some point in working on those small farms, I started to think about, well, what is it that that makes the big farms work? What is it that moves the big quantities of food around in the world? And what are the environmental consequences of those big farming systems? So I went back to school in Wisconsin and I studied carbon cycling and different cropping systems. And I tried to learn really about those big picture systems. I've been here in Minnesota with my family for a couple of years in this position as the state soil health specialist. And as she said, I think about organic matter, cropping systems, what we can do to improve soil sort of broadly from all these perspectives. So soil health is this buzzword with this definition from the NRCS of the continued capacity of the soil to function as a vital living ecosystem. And it gets a lot of traction these days, I think largely because it's such a positive concept. With some ideas about quality or improvement, there's kind of a maximum for how good you could do. But with health, there's always something you could do a little better, right? Like I could have exercised a little more today or eaten a little healthier or what have you. And it's the same with your soil. There's kind of only positive direction to go in. Soil health also encompasses kind of a benefit for the farmer and a benefit for the society in one concept, which I think is really important socially. Today, I'm going to talk more as we go through here on essentially how the soil functions, what functions we demand from the soil, and really across the landscape, thinking about the agricultural landscape, what are the things we can do to improve those functions to make our soil more healthy. So I'm going to go right back to the beginning about what is soil. This pie chart breaks it down into 4 components. And one thing that is really striking is that half of the soil is essentially solids and half of the soil is essentially space that could be filled with air or water. And this represents the space or the pores being half air and half water, but that's going to vary depending on the conditions. Right after rain, you'll probably have a lot more water in there and a lot less air. But it's important to remember that all these components are working together. The mineral solids, creating space for the air and water, and then the organic material, which I'm going to talk quite a bit more about, but which represents a really tiny amount of total mass in the soil. So this is one way to look at what is in the soil. And then I think this figure is important as another view of what does the soil look like. So this is an X-ray tomography view where you can essentially see the solids on the left and the pore space on the right. So this is how those 4 components that look so tidy in the pie chart actually interact on the landscape. When I look at this, I think, oh my gosh, no wonder so many pieces of research about soils are still so up in the air. There's a lot of tiny environments in between all these solids where different organisms live and different processes happen. And what you measure from the soil as a whole may be dominated just by what happens in one little tiny pore, or it might be kind of a mushy average across all the space in the soil. So it's this incredibly heterogeneous medium, both on this micro scale that I'm showing you now, and also across the landscape. When you look across a farmer's field, they're going to be able to tell you, well, that acre tends to be this way and that acre tends to be that way. And I've had better luck over here with this practice. There's a lot of variation on a lot of different scales. So maybe I'm just going to start out there by giving that big caveat for why some of the things we say, we just don't know as clearly about soil as we would like. But that's one of the reasons I've really enjoyed studying it, is because I do find it mysterious and interesting, even after thinking about soil for the better part of the last decade. So I'm going to go into talking a little bit about soil organic matter and how it relates to soil function now. So soil organic matter is something you can get out of a soil test. You'll get a number like 5%, 3%, 10%. And that has to do with the total mass of things that are essentially burned up when they put a tiny sample of your soil in the oven. They assume that that mineral portion of the soil is not going to burn because it's rock, but the pieces of carbon based on living organisms are going to burn up. So that's all your organic matter. When you get a number like 5%, it's important to keep in mind that behind that, you have this whole set of organisms, living things, dead things, and different little bits of their bodies that have stuck around for some number of years or decades or millennia in the soil. This is a really simplified version of a food web, showing that some organisms, like the little microbes I've represented here, or the little worms here, do feed on plant roots directly. And then those bodies of microbes tend to be recycled into other bodies of microbes and other bodies of microbes, on and on and on. And they also feed larger organisms in the food web. Some of the ones that are represented here are a collembola, a nematode, a mite, a millipede. So there's just quite a few different organisms there. Sorry, this is the mite. The other piece of the food web I've represented here is the carbon dioxide released from it. Just like us, microbes eat carbon-based food and they breathe out carbon dioxide. And so while we, in some cases, talk about minimizing the amount of carbon dioxide that comes out of the atmosphere, comes out of the soil. We also need to recognize that that is an inherent part of having living things in the soil, is having some carbon dioxide coming out. So when you see that organic matter percentage, if you get a soil test done on your garden or farm, keep in mind that behind that are a whole bunch of different organisms. And tying that back to that messy pore space structure I showed, I wanted to talk about where these organisms live. One of the most basic properties of soil is the texture of the soil, which we determine by talking about the proportion of sand, silt, and clay in your soil. So sand particles are about 2 millimeters in size, in diameter. They tend to be fairly spherical. You know, they look like a grain of sand. You can picture that. Silt is much, much smaller, and clay is much, much, much smaller. So when we think about these particles, that size is one of the main things that defines how they behave in the soil. There's a lot more surface area in a small particle than in a large particle. And so clay becomes kind of the most dynamic habitat that we're interested in. This is what it looks like if you zoom in on a bunch of clay particles under a microscope. I always think it looks like a paperback that you dropped in the bathtub and then pulled out and let dry. It leaves a lot of nooks and crannies between all the clay surfaces. And that's where the organic matter, the organisms, live and stick around. Clay surface area is also charged, which helps it to hold on to different kinds of nutrients and organic matter. And so the amount of clay you have in your soil tends to be a huge determinant in how much organic matter you can keep around in your soil. Can also determine other properties in terms of the structure and how much water drains through and that kind of thing. I'm focusing mostly on organic matter right now. I should point out here, I have as my title, clay surface area holds carbon. And previously I'd been talking about organic matter. To be perfectly clear, organic matter is about 50% carbon. They're measured in different ways, soil carbon and soil organic matter, but functionally, they're pretty interchangeable. Researchers like to use carbon because it's more precise, and farmers and gardeners use organic matter because it's cheaper to measure, and they're both fine. So I may go back and forth a little more. The next level of structure we're interested in is soil aggregates, and this is where it really gets interesting. So if you can imagine that clay with all that surface area that we saw in the last picture, and it gets coated with little bits of organic residues from dead microbes and living microbes and little old bits of plants that haven't fully decomposed. And that kind of is sticky, and it snowballs essentially with other clay particles covered with carbon, into these tiny aggregates. So this figure, I'll just point out the scale. 250 microns is 1/4 of a millimeter. If you can imagine in a mechanical pencil, the lead is about 5 millimeters. So when we're talking about this soil aggregate, it's 1/20th the size of a piece of pencil lead. This is on a really small scale. When you think about the beautiful soil structure you can see in your hands, though, it starts at this scale. So this scale is still important. So at this tiny scale, you've got essentially your tiny micro aggregates that are built of those snowballs with clay and organic matter. You've got little chunks of what they call debris in this picture. You've got the microorganisms themselves living on the surface. And you've got some stringy, larger organisms that are easier to recognize. These are roots in the green mushy stuff. And these are fungal hyphae, the stringy bodies of soil fungi in the red and the yellow lines here. The other important thing that's represented in this diagram is the space between the particles. Remember I said half of the soil volume is actually space between particles. And they show some of the big particles here, big on this scale, again, not really that large, but big on this scale. They show being filled with air, and that's good. And then they show how some of the spaces or the pores on the small scale are filled with water. That's because water is held more tightly in smaller pores. And so this gets into that function piece that I brought up with the definition of soil health, because the interaction of the soil medium with water represents some of the most important functions we care about for growing plants and also for ecosystem services. So those soil aggregates I've been talking about are really important for letting water into the soil. This figure here on the right shows soil from two directions. Either you look down at the top of the soil, so this is, for example, if you cleared away the duff or whatever you have on top of your garden, and you could look right down at the surface of the soil. This is a less aggregated soil where things are fairly smooth. You don't see a lot of different sizes of particles, and the particles are pretty small. If you look down at this soil on the right, you see some bigger chunks of soil, and you see kind of more diversity of different particle sizes. When you get to the interaction with water, this is from the Cornell Extension Service, they've portrayed that with these blue lines coming down. And now we're looking at the soil as a cutaway. So right here represents the surface of the soil in both cases, with the lines representing rainwater, presumably coming down. And you see in the soil on the left, there just aren't big spaces between those small particles, and the water can't enter. And this is what happens when you have a soil where the structure is broken down and all you have are essentially tiny pieces of sand, silt, and clay that form more of a paste, a glue, instead of this well-aggregated medium. You don't have those diversity of different sizes of pores you could see in that original thing I showed you. On the other side, you have bigger spaces between the aggregates that let the water in when it rains. This is one of these most important functions we need from our soil. If the water can't get in, it's not going to stick around for the long term for your plants to use it. And if the water can't get in, then it runs off over the surface and you lose it. And you often take nutrients and some of the soil with it as it flows over the surface of the soil. So this is like one of the most primary functions of the soil that we want in a healthy system. The other piece that I added to this Cornell visual was the little bubbles inside the aggregates, because really it's the opposite function, but we also want the soil to hold the water for the long term. We want it to let it in and through quickly so that we don't have ponding on the surface or runoff, but we also want the soil to hold the water for the long term. And so having these tiny pores inside aggregates gives us some opportunity for long-term water storage, even as we also allow water to flow between the large aggregates as infiltration. So this is a pretty diverse set of functions. It's pretty extraordinary that we're able to get them both. And really the only way we're able to get them both is through this kind of structure. There's a pretty clear relationship between total soil organic matter and infiltration. This is from some data that was taken around the state of Minnesota, which is pretty messy, but shows the general relationship that as you increase soil organic matter, you increase infiltration. And that's because you've got that interaction where the organic matter builds the structure that lets the water in. In this same study, this is from my colleague Jess Gutknecht, they also simulated a 50-year storm with this incredibly fancy research device involving a mini sprinkler on the surface, where they were able to measure the runoff and nutrient loss through that pan and 5-gallon bucket setup. And so in that case, these are the two kind of twin components. When water comes in, either it goes into the soil or it runs off across the surface. Those are sort of the two primary ways that water can go. And if you see infiltration goes up with organic matter, runoff, the opposite pool of water, goes down as you have more organic matter. So in this case, that's a good thing. You've got more organic matter, more structure, you're losing less water. So there's a bunch of data behind this, but this is the stuff I have on hand from Minnesota. Expanding from that, this is data compiled from many studies looking at the relationship between infiltration, so again, how much water goes in different cropping systems. And the way this figure is set up is that the level of blue in the soil represents the infiltration rate. And so a conventional system with livestock grazing or with no-till didn't have that much effect on the infiltration rate. Same thing with a longer crop rotation, so having a 5 or 3 crop rotation instead of just 2. The things that did increase the infiltration rate across studies around the globe, so there's probably differences in different contexts, but the things that universally increased infiltration rate were including a cover crop and including perennials in the system. And that's because you kind of get dual benefits when you use those practices in your system. You not only get the increased organic matter that can give you that structure, but you also get the channels of the roots themselves that can act as channels for water once the roots have died or even alongside the roots. Okay, so this I think is most of the background I have in terms of how soil works and what functions we're going to talk about. Now I'm going to talk about the soil health principles and a little bit about what we can expect from different practices on the ground. So the soil health principles you may have heard before, but I'm going to go over them because I do think they're important. They really cover a lot of what we're talking about here. The first is simply to keep the ground covered. And you can see the difference between the picture on the left and the one on the right. And you can imagine, again, trying to get water into that system on the right. You're not going to get it in except for through those cracks. And I bet that even under those cracks, infiltration is not going to be fast. Keeping the ground covered protects that soil surface structure, and it also just makes it harder for soil to blow or flow away. And if you're losing soil, you don't have healthy soil. That is definitely a baseline. Minimize disturbance. This is a picture of a strip tilled field. So you can see there's tillage just exactly where they're going to plant the crop and not in between. And in this case, reducing that disturbance means not running a tiller through the ground that could destroy those soil aggregates. Since soil aggregates are held together with stringy things like roots and fungal hyphae, they tend to be more vulnerable to tillage or to any kind of mechanical disturbance. The third principle is to keep living roots in the ground. And this has to do with a couple of things. One, the channels that roots create that I mentioned before can add to the function around infiltration. The other is that microbes live right on the surface of roots. More nutrient cycling happens on the root surface than anywhere else by an order of magnitude. So this is a really important food source for microbes, and it's sort of the basis of that food web that I showed you earlier. A fourth principle is to diversify above ground, and this gets at the premise of trying to give your food web a diverse diet. Diversifying above ground also can give you some economic resiliency depending on what kind of year it is. For example, in the wet springs that we've had over the last few years, people who had some of their rotation in small grains where they weren't all trying to plant every one of their acres during a wet time, had some acres they essentially didn't have to worry about during that wetter spring. Integrating livestock has both a biophysical component and sort of a socio-economic component. Biophysically, having livestock in the system gives you manure, which is an amazing carbon source for your microbes and the whole food web. It really seems to do something for soil structure and soil biology that no other carbon source can. But importantly for farmers looking at trying to diversify their systems, having livestock in the rotation gives them a reason to grow a cool season crop, something like a forage crop or a small grain, gives them an economic outlet for that. So it's incredibly important to reintegrate crop and livestock systems from the perspective of making soil health economically viable for farmers. So all these principles kind of work together. In an ideal system, maybe you'd have them all going at once. Maybe in some cases, you've just got some of them going in some fields and some of them going in other fields. Some practices that I've talked about in relation to these, which are really common, are reducing your tillage system. I showed that picture of strip tillage, and looking at a no-till system is also a step in that direction. Looking at cover crops, being a crop that's grown outside of the summer annual growing season. So in Minnesota, that looks like something you're probably planting in the fall and killing in the spring before you plant your next cash crop. Integrating livestock might look like grazing that row crop land or your cover crops, or it might look like a pasture-based system. I'm going to just show a little bit of a chart here with not 100% quantitative, but relative data showing how effective different practices are at meeting different goals. So soil health broadly can encompass a lot of things. I've talked mostly about carbon here because that's what I think about from the soil scientist perspective. But from the larger perspective of environmental stewardship, water quality and climate resilience are pretty high on our radar also. So a practice like reducing tillage, for example, that does check off some of these soil health benefits and is really critical for stopping the huge amount of soil that blows around Minnesota every spring and fall. It's maybe less effective at soil carbon storage because it tends to just redistribute the carbon in the soil profile rather than actually increase the total carbon in the profile. Because you're not blowing soil around, though, you do have a water quality benefit, which is really important. And you do have some climate resilience benefit because you tend to keep your soil structure around and hold on to water in an intense rainfall more. Cover crops have a lot more of a water quality benefit because they can directly take up nutrients when other systems are not kind of functioning because there's no corn growing in November or March. They're not especially effective at soil carbon storage at this stage in Minnesota, largely because they just don't grow enough over the winter. We just have such a short growing season. If people can really maximize biomass, then that soil carbon storage number can go up. But on average, it's not as impressive as their ability to work on water quality. In climate resilience, again, thinking about that infiltration function, cover crops can have a pretty big effect. The real game changer is when you move into perennial cover, where you have the water quality benefit from something that's there year round. You can actually get some soil carbon storage going, and you have more resilience to different climate events because you're not thinking about trying to plant or harvest in quite as narrow a window. Although with alfalfa, which is a common perennial forage crop, they actually can be pretty sensitive to periods of drought or overly wet times. The first two practices here that I've listed represent essentially incremental tweaks to an existing system, where a perennial cover system represents a real dramatic change to what most farmers are doing on the landscape. And so when I think about what any farmer can do around the state of Minnesota, I still focus a lot on those first two practices, even though they might not be the very best. At this point, changing your system requires a lot of work, and I want to respect what farmers are able to do on the short-term time scale. I'll also, let's see, I have some more information about cover crops here, but I don't want to inundate us with data. So I'm just going to skip through some of this unless you want to come back and talk about cover crops more, and point out again, just that cover crops can mean a lot of things. And if you're comparing this cover crop system to this non-cover crop system, you're going to see a night and day difference in terms of what happens on a landscape. But if you can even figure out which one of these is the cover crop system and then compare them, you're not going to see as strong of a signal. So cover crops are this really promising system that still needs kind of a lot of research, and largely because we're not sure when you say I planted cover crops, which system you're going to get. It's going to depend on the year. It's going to depend on your soil. You know, some years, some systems work really well, and then the next year they don't work quite as well, just depending on timing. This other piece I wanted to bring up about perennial cover also, it comes from this work from Greenland's Blue Waters and the Midwest Perennial Forage Working Group, where they put together this graphic pointing out that while perennial cover is more effective for carbon storage, it's also really effective for infrastructure protection in rural landscapes. Flooding can cause huge amounts of economic damage in rural landscapes, and perennial cover, because of that infiltration function, can kind of reduce the load on culverts and bridges and roads and all those pieces. So I'm going to wrap up here and just say that there's really no easy answers in how to grow crops and steward soil. I really like this figure from the 30s, though. It emphasizes that we all rely on soil, and the farmer has this interesting dual role as user and protector. We ask a lot of our soil, and we ask a lot of our farmers, who have a lot of constraints on their decision making, but a lot of power to affect the environment we all use. And this concept of the farmer and all of us as stewards has a really big picture connotation, right? It's much bigger than any one landowner or citizen. So, the land is shaped by glaciations tens of thousands of years ago that we really can't imagine. The soil is formed under prairie over thousands of years. People and animals used the prairie before we got here. Their grazing and burning practices changed the soil that white people came in and have used for the last couple hundred years. And we don't really know what comes after us. So one thing that's, I think, really fun about looking at your soil health is that you enter into this long relationship with your soil. It connects you to that history and also to the future users of your land. Doesn't change fast, but it is a big and meaningful process to be involved in on the planet. Please do get in touch if you want to talk more about this stuff, and I'll be here for the rest of the talk tonight.
We do have some questions that have come through while you were talking. So why don't we go through them really quick? So the first question is, I have a soil map which shows that I have Duluth fine sandy loam. Does this tell you that anything about clay, sand, silt, gravel mix, or how porous it is?
Yes, it absolutely does. A Duluth fine sandy loam should be a pretty nice soil for working in because you have a little bit more sand than clay. So in some ways, infiltration is not going to be your problem. Anything which has sand in the name of it is going to have better infiltration naturally, and it's going to hold on to less organic matter naturally. So thinking about more organic matter additions like compost is going to be really important for stewarding that particular soil. And also having realistic expectations about how much organic matter it's going to gain. It's not going to look as good as a clayey soil, but you're going to be happier after a rain.
Fair enough. So the second one is, this makes me question whether sifting garden soil is beneficial with that compost prior to adding it to a garden.
So it depends what context you're sifting your garden soil. I'm thinking a lot of times you do that when you're getting ready for seedlings, and seedlings are picky. That's why farmers till the soil, is because that's their way of sifting on kind of the massive acre by acre scale. So there's a reason for it. You'll probably get better seedling emergence, and it's because when you think about that mix of air, water, and mineral space, your roots need a lot of that air and water, especially for a developing plant. In the long term, is that going to give you soil that's going to be really resilient in the face of a rainfall? Maybe not, but on the scale of doing a few seedlings, it's probably all right. We worry about it more on the landscape scale.
Perfect. Okay, so the next question is, on a smaller scale, how do you keep weeds down in a garden? I'm interested in doing less tillage in my small garden.
I don't have a great answer for that. All I ever do is go out there and pull weeds until I get tired of it. One of the ways that this works on a landscape scale is by using pesticides and crops with genetic resistance to those herbicides, using herbicides in crops with genetic resistance to those herbicides. So herbicides get a bad reputation, and certainly they're not a healthy substance to be around in the long term, but they really enable farmers to reduce disturbance, build good structure, and reduce erosion.
Okay. And how do you manage soil compaction with minimal or no-till systems?
Yeah, I would look into crops that have different kinds of root systems. So crops like a tillage radish that have a really deep tap root that can kind of break up a hard pan can be helpful. But you'd want to mix that up with something that had a more fibrous root system that could kind of also break your soil up into little aggregates. It'd probably go slow. I would pick something that grows fast, like oats, perhaps. The Midwest Cover Crop Council has a good cover crop selector tool, and I think compaction fighter is one of the attributes you can suggest for your cover crop. I'll put that link in after we're done talking.
Yeah, that kind of leads into another question that we got. What cover crop recommendations do you have to turn heavy clay into a good medium for a larger scale garden? In my particular situation, I'm looking at converting 2 acres into a market garden, but it's heavy clay.
Yeah. Well, it is a hard go with the heavier clay. It's just a lot harder to work with in different, both dry and wet conditions. I think that the best you can do is to try and keep up some kind of cover cropping. So you're getting those roots in the ground year round. And again, you can look at that cover crop selector tool to think about the different kinds of root systems that you'd want to see and mix that up. And then doing some rotation. So even if you have to till some areas to prepare a seed bed, trying to make it so you don't have to till every area every year. If you have the land base to do that, would be ideal.
Okay. Can you give an example of a perennial cover and how is it used?
Oh, sure. Yeah, that's a great point. I didn't define that very clearly. When I think about perennial cover on the landscape, I think of it in terms mostly of forage crops. So cool season pastures, warm season pastures also. Sometimes people continually will actually plant full season cover crops. So they may plant new species every year, but their goal is still to have something growing all the time. Perennial just means something is growing year round. You can count something like alfalfa, which is the sort of standard commercial forage crop, also in that realm.
Okay. So the last question, and Jim and Leanne, you might have to come on off mute to kind of clarify a little bit, but they asked for us to talk more about the best balance between water and air in a clay soil and how it relates to soil life.
Yeah, no, I think I understand what they mean.
Okay.
Microbes are not so different from us in terms of how much oxygen and how much water they like around. And that 50-50 balance is ideal. The problem is when you can't control how much water comes into your system, which is basically true unless you're gardening inside. And then it's on you if there's too much water or too little in the system. Yes, so microbes can function. They obviously survive saturated conditions if there's big rain and the soil is completely full of water. But if that persists for a long period of time, both your plants and your microbes are going to suffer from lack of oxygen. So hitting that 50-50 zone is going to be good.
Okay. And last question so far is, do roots grow in the presence of water or do they seek it out?
That's a good question. I don't know if I can answer that very precisely. I think it might be kind of a chicken and egg condition where roots are going to always be seeking water, and then they're going to stay and proliferate in places where there are water. But once again, most roots don't like completely saturated conditions unless you're looking at wetland plants that have kind of a different capacity than most of our food plants.
And we got one more question that came through. What perennial cover would you recommend for saturated conditions?
I'm not going to be able to think of any species off the top of my head. But again, the Midwest Cover Crop Council is a good place to start. And then I might be able to come up with something after I think about it here for a few minutes.
Okay. So we are going to move forward. I am keeping track of any other questions that come in. I saw 2 just came in, but I want to make sure that we give Laura plenty of time to talk as well. So thank you. Professor Cates. I really appreciate this. So let
Thanks,
me kind
everybody.
of, let's see. So I'm going to introduce Laura. So Laura Schreiber is the policy organizer for the Land Stewardship Project, a nonprofit dedicated to creating healthy, vibrant rural communities and a more sustainable and just food and farming system. She co-leads LSP's Soil and Health and Climate Change campaign, fighting for statewide investment in soil healthy farming practices, and organizes our members at a federal level. She graduated with degrees in urban studies and public relations with focuses on sustainability and policy from the University of Minnesota Twin Cities in 2019. So thank you for joining us, Laura. If you don't mind taking it away as well.
Yeah, absolutely. Thanks, Laura. So I'm gonna share my screen and have a little presentation for you all, but wanted to give greater context to, was invited to share about, like Anna was saying, it's difficult for farmers to branch in to new practices. So we've been fighting at the state level to how we can make it easier for farmers to do soil healthy practices and invest in them. So going to be sharing a bit more of the policy side tonight, but here we go. Okay. And then let's see. Okay, can everyone see? Is that okay? Nod head? Yeah. Okay, great. So yeah, I'm a policy organizer with LSP. We are a people power organization. We're member-led and mission-driven. We're dedicated to transforming the farm and food system and achieving rural economic justice. We have about 4,500 member households, and we're about a third farmers, a third rural, and then a third suburban and urban. And our mission really is to create a world where small and mid-sized businesses are thriving, including farms, local markets, local processing, and land is accessible, and stable and sustainable jobs are abundant, and all people can make living wages. So we're fighting for policy change, both in soil health, but also healthcare, making sure our communities are funded. We have our program staff, which does soil health, working directly with farmers and getting people access to land. So if you have any questions about our different programs, I can take those later too. But this year, we started our soil health and climate change campaign. So this past summer, we did tons of one-to-ones and surveys and talking to our members and supporters and really asking the question of what do we want to fight for at the state legislature and what kind of policies and investments do we want to see in our farmers to make change on climate change? Because one of our strategic initiatives is to really be a leader in investing in our farmers and how we can be a climate taking action state. So with that, we did tons of different listening sessions, surveys, talking to people. And what was born out of that was this mandate really from our members, like we need to see landscape scale solutions to the climate change crisis. So, you know, really trying to make change at scale, like what's happening. And like Anna just shared, all of our conversations were born out of this idea of the 5 principles of soil health. So making sure we're armoring the soil, minimizing soil disturbance, increasing plant diversity, keeping living roots in the ground, and integrating livestock, like Anna just shared with us. And with that, we built, let's see if we can go forward. 1 second. Okay, so we, with our core organizing team of 15 farmers, members in both suburban and rural areas, came together and built a bill that set statewide goals to have 50% of farmers using soil healthy practices by 2030, 100% of farmers by 2035, and then 100% of acres by 2040. And we're doing this by launching accessible grants so farmers can be paid upfront for investment in, say, they want to do managed rotational grazing, so fencing, getting new equipment, seed, what have you, like helping them decrease some of that risk of doing a new practice. So providing upfront payment and then continued support over 5 years. So it usually takes about 3 to 5 years for farmers to see these changes on their landscape. So with this bill, really wanted to show like, or take away some of the risk of transitioning new practices. We also wanted to prioritize socially disadvantaged farmers. So Black, Indigenous, people of color farmers, women, disabled, and small and mid-sized farmers. Traditionally, funding has, mainly gone to the biggest of the big. So we really wanted to focus in and make sure support was going to communities who have been historically disadvantaged. And part of what Anna was sharing is like, depending where you are in the state, your soil can look so different. So we wanted to track the percentage of soil organic matter that is being grown by these different soil healthy practices, and making sure that we have research and can see what's working and share that information out. So some of the different practices that make up soil healthy farming is managed rotational grazing. So like Anna said, like getting livestock back onto the land, grazing them in perennial pastures. We have some of our farmer members are literally out there 2 or 3 times a day moving their animals around in different parts of their pasture. Some, it might be once a week. So it just kind of depends on your size and scale. Perennial cropping, so having living roots in the ground all year round, no-till, implementing diverse rotations. If a farm wants to switch over to organic, helping with those costs of switching there, reducing pesticides, cover cropping. So this is kind of one of the easiest, supposedly, or, depending on the audience, but an easier way to break into soil healthy practices and making that more accessible to more farmers. And also farm generated compost would be included in these soil healthy practices. So you can get upfront payments for like fencing, seeds, what have you, but then depending on the practice, you get that sustained payment over 5 years of continuing this practice. So at the legislature, we introduced this bill this back in February, and we've had 24 representatives have signed on to our House bill. It's being championed by Todd Lippert down in Northfield. He's been a really great ally to work with. And he also took one of our farm beginnings classes. So it's kind of full circle with our relationship with him. So pretty cool to see our representatives fighting for investment in farmers. We have Senate Bill 2. It has 4 senators who signed on. We've seen great bipartisan support. In the Senate, we have Democrats, independents, and Republicans who have signed on, which is great. So our House bill passed out of the House Agriculture Committee 11-1, which was awesome to see. Again, such great bipartisan support. It's kind of unheard of right now in our current legislature. We're divided, Democrats in the House and Republicans in the Senate. So it was really great to see that. And then we moved on to Judiciary Committee and passed there 9-4. And we've been having, our members have been lobbying, talking with their legislators like, hey, we really need to invest in soil health. This is what I'm seeing on my farm. I need to have access to those types of funds, making sure that our decision makers know that soil health is something that Minnesotans want to see invested in. We're also holding in-district meetings with key representatives and decision makers. So as we're moving on a legislative process, we're at a key time now where different omnibus bills have been dropped, and both House and Senate have their versions, and making sure that money for soil health can stay in there. So right now, our bill is no longer moving as a standalone bill, but it is included in the House Legacy Finance Omnibus Bill. So a bit wonky and jargony, but so we had $11.3 million that's going to be set aside for those soil healthy farming grants and payments. So we were thrilled to see 11.3 million. We had originally only asked for 5 million. So I was really excited to see such bold leadership on the part of Rick Hansen, Representative Rick Hansen. Part of our goals were included in the House Environment Omnibus Bill. So instead of doing the 50% of farmers by 2030, 100% by 2035, we got 30% of farmers using soil healthy farming practices by 2030. So, we still see this as a great win, a great step. and conversations are being started. So that's always a win for us. And also there's a 1 million included for soil health, a cost share program. So making it easier for farmers to share equipment, you know, if even like animals can be included, if you want to do grazing. So this is like a great way of like keep building soil health momentum and making it easier for farmers to implement on farms. So kind of cutting into the nitty and gritty, but so right now, like we're in that time of committees are coming into conference committee where both House and Senate come together to decide what's going to make it to a floor vote and what's actually going to get put before the governor and signed into law. So it's really important that our legislators are hearing from us right now that we want to invest in and support soil health. So we have a petition that's almost at our goal of 2,500 petition signatures, and we're presenting that to governor and also key decision makers at the legislature. So I'm going to share in the chat all these links too, so you have them, so don't worry. So you can sign our petition and share with your friends, colleagues, different groups that you're in. It's really important that decision makers hear that this is something we want to invest in. We're also doing an action alert right now, like sharing why you care about soil health. For me, something that I think is so powerful is even if you're not a farmer or, you know, have land, like soil health though is something that impacts all of us and connects all of us. So making sure that our farmers have the resources that they need to really do farming that provides both a public good for all of us, clean air, better water, and having more resilient soil in general, something that impacts all of us. So sharing out how this connects to you. And again, I'll put these links in the chat so you all have them. We are hosting, usually every year we do our family farm breakfast at the Capitol. It's great. We all gather in the church across the street. It's packed. There's like 300 people in a room that there's only supposed to be 250 and have great local food. But instead of that this year, since, you know, still virtual, next Thursday, we're gathering at 7:30 a.m. bright and early, but it's been great. And hearing what our members are doing at the Capitol, what work they're pushing forward, and seeing how you can get involved too. And for federal level action, you know, right now is a really key time. The USDA is taking public comments about how they can take action for climate smart agriculture. So we have an action alert that you can sign on to and add your name to be like, hey, we should be investing in small and mid-sized farmers, soil health, doing away with factory farms. It's not the type of farming we should be investing in, and also fair wages for farmers and farm workers. So I can drop all those things in the chat as well. But you know, policy is so important, and it's one of the levers that we have to see changes on the landscape. So I'm really excited that, you know, this money is being allocated, and we're going to continue to fight for it, make sure it makes its way through to the end of the legislative session. And all of your help and support is critical in that. So sign the petition, sharing with your friends, contacting your representatives too. And if you have questions about any of this, like, I'm a resource, let me know, I will plug you in. But yeah, so here's my information. I'm gonna take down slides though and want to take questions. I know I went through that pretty quickly, but I wanted to keep us on time. So, and I can also add those things into the chat. But here, let me stop. Sharing. Okay. So.
Okay. If anybody has any questions, please put them in the chat. We are happy to answer anything. Thank you, Laura, so much for covering the policy side of it. And I will be actually sending out all the links that have been shared in the chat as well. So if you end up missing a link tonight, you will get an email along with this recording, so you don't miss out on any of the information that was shared today. So does anybody have any questions at all? You can come off mute even if it's a little bit too much to type or anything. I'm getting a thumbs up from Alan.
Yeah, and I should mention too, so for other states that have done these types of programs where they're incentivizing farmers to do soil healthy practices, like this is happening in Indiana, Maryland, parts of Iowa, but for instance, like Maryland, they have 50% of their land is now in cover crops after incentivizing their farmers to do these practices. So it's really exciting to see what's possible if we invest in our farmers and sustainable farming too.
Well, thank you everyone for joining us. If nobody has any burning questions right now, if you can think of anything, if after this Zoom meeting is done, you come up with a question that you really want to know the answer to, don't hesitate to email me. I am happy to answer. Oh, Melanie is wondering if we're working with any other organizations with the bill. So.
Yes, so we have been working closely with the Board of Water and Soil Resources and a lot of different, we've had an organizational sign-on letter, but there's about 20 different orgs who are in support of this, but Sierra Club, MN350 are supporting lots of different groups that I could also follow up with you and let you know. But yeah, lots of different environmental groups and farmers all across the state for sure.
Okay. So I am going to get this recording to you as soon as possible with all of these links. Otherwise, if nobody else has any other questions that come to mind, thank you everybody for joining us. A huge thank you for both of our presenters. It was absolutely wonderful to learn all of this new information, learn about the policies, learn about the background, learn about cover crops. There's so much information that we had tonight. So thank you.
Yeah, thank you so much, everyone.